So this is where we're going to start talking about wave interference and how two, or I guess more waves can interfere with one another at a location to create different types of waves than what we would normally have in just a single wave. So the principle we're going to talk about today is what's called linear superposition. And this is one way to begin to think about waves as they interact with one another. And I have a little picture here on the right which kind of describes what happens. When two or more waves are present in the same place at the same time, the resultant disturbance is the sum of the disturbances caused by individual waves. What this means is that when waves interact with one another, they add together, or they maybe cancel each other out if one was a downward wave and one was an upward wave. So here in this diagram I have a big wave starting on the left moving to the right, and I have a little wave starting on the right moving to the left. And in the second picture they start to interact with one another. And in the third picture, they're now at the point where the two crests of the two waves are in the same location at the same time. What happens is the resulting crest is the sum of those two crests. So we get a big wave for that instant in time, and then the two waves continue to pass through one another, and by the end you have a little wave moving to the left on the left, and a big wave moving to the right on the right. These two waves basically pass through one another, and that's that. I'll actually do some demonstrations where I show superposition actually occurring in a set of waves. This is actually a really cool phenomenon, and it happens all sorts of places. This happens in ocean waves, it happens with sound waves, it happens with light waves, it happens with any type of wave that exists. What the end result of this is that we can actually have two waves interact with one another in a way that we would call interference, or that creates interference. And here I have two ways, kind of the two extremes of interference. One, I have A and B. These are two waves with the same wavelength, and where the crest of A always matches up with the crest of B, and the trough of A always matches up with the trough of B. The fancy term that we talk about in physics with these two waves is that they are in phase with one another, meaning that crests always line up with crests, troughs always line up with troughs. What happened in this case, if A and B are both the same frequency and in phase with one another, you're going to get a wave that is the sum of A and B as your final interference. Now, on the other hand, the other extreme case is what if you have A and B that are the same frequency, but the crest of A lines up with the trough of B, and the trough of A lines up with the crest of B. In physics, the vernacular in physics, we call this out of phase, or exactly out of phase with one another, meaning that crests line up with troughs and troughs line up with crests. What happens there if we add those two waves together is that they cancel each other out, and we end up with no wave. This would be one way if you're doing something like sound canceling technology. You could do that is to create a wave that is exactly out of phase from the waves that you're hearing from some external source. So if you have those really fancy sound canceling headphones, that's really what's happening. Or in something like a really fancy luxury vehicle that has the sound canceling technology, there's actually a sound being played by the speakers of that vehicle which cancels out the engine noise of the vehicle. Basically in this way, creating a sound that's exactly out of phase of the engine noise, and therefore the two waves interfere with one another and cancel each other out. In the next lesson, we're going to look at interference from a mathematical perspective and look at how can we begin to predict what's going to happen in both of these cases. These cases on the left we would call constructive interference. They add together. On the right we call that destructive interference. And so there are some ways that we can talk about this with multiple sources of sound. How can we begin to predict where are locations of constructive and destructive interference?